The question here is, what is an IP address? Well, the most simple answer that I can give right now at the beginning is an IP address is used to identify computerized equipment connected to a network. Each one of these groups of numbers is called an octet. So there are 4 octets within an IP address. There are 3 classes of IP addresses, class A, B, and C. Now, class A IP addresses are IP addresses where the first octet of the IP address is between 1 and 126. Now, 70 is between 1 and 126. So this IP address is a class A IP address because the first octet is 70. Now for class B, any IP address between 128 and 191 falls into the category of class B. Now this IP address starts with 131, which is between 128 and 191, so this is a class B IP address. Now for class C, which is between 192 and 223, this IP address starts with 203, which falls between 192 and 223. So this is a class C IP address because the first octet is 203. Now we also have class D IP addresses. These IP addresses are used only for multicasting purposes. They're not used for networking. And class E is reserved. So the IP addresses that we'll be talking about today are class A, B, and C. Included in every class of IP address, class A, B, and C, are public and private IP addresses. Now, everything in class A section from 1 to 126 is public except for this range of IP addresses from 10.0.0.0 to 10.255.255.254. Everything else is public. In the class B range between 128 and 191, everything is public except for the private range, which is 172.16.0.0 to 172.31.255.254. Now in class C, the range is 192 to 223. Everything is public except for this private range of 192.168.0.0 to 192.168.255.254. Private IP addresses are used on local area networks. This is a way to conserve IP addresses. If we had to assign a public IP address to every device on the face of this earth, we would not have enough IP addresses. So that's why private IP addresses are needed. You're free to use any number of private IP addresses that you wish. Now, public IP addresses, on the other hand, are owned by the ISP, and they will lease these IP addresses to you. Like for your home, for instance, you're given usually a dynamic IP address to your router, a public IP address, and this IP address changes periodically. Now for companies, they would purchase a range of IP addresses, public IP addresses, for the web server, for the DNS server, and different servers that they may have that would be interfacing with the public network. Private IP addresses are needed for any device that requires an IP address but is not on the public network. Public IP addresses are used for the public network. Every computer on a network requires an IP address, and every IP address on a network requires a subnet mask. Now here we have a class A type IP address. As we can see here, the Class A range is between 1 and 126. So we have an IP address starting with the first octet being 10. So this is a Class A IP address. Now underneath here we have a Class A subnet mask, which is 255.0.0.0. Every IP address has two areas, a network area and a host area. How do you know which part is the network and which part is the host? All depends on the subnet mask. The area in the IP address that lines up with 255 in the subnet mask become the network area. The areas in the IP address that lines up with zeros become the host area. So 10 will be the network and everything else be the host for Class A type IP address. So the first octet is always the network for Class A, and the rest of that IP address would be the host area. Now let's say we wanted to assign this IP address to a local area network. Now each and every computer on that network would have an IP address starting with the number 10. The very first octet of that IP address would be 10. If you should change this number to another number on one of the computers, that particular computer would not be part of this network. Now the second octet of the IP address for each computer on the network would range from 0 to 255. The third octet would also range from 0 to 255. Now the fourth octet would range from 0 to 254. The reason I said 254 is because we use .255 for broadcast traffic on the network. And what I mean by broadcast is, let's say you had a local area network with computers on there. Each and every computer would be assigned an IP address. But if one computer wants to send information to another computer, it needs the MAC address for that computer. So in order to get the MAC address for that computer is that it sends out an ARP request. An ARP request is a broadcast message. And this broadcast message goes out on the broadcast IP, which is a .255 IP address. Now all of the computers on that network hears this broadcast and they stop and listen. But only the computer that request was made to would actually respond with its MAC address. So that's basically what the broadcast IP, which is .255 IP address, is used for. Now on a Class A network, we have a maximum of 16,777,214 hosts. Now Cisco recommends that you have a maximum of 500 hosts per network. Hosts per network is computers per network. It's the same thing basically. So what is done in order to reduce this is by subnetting the network. Subnetting means dividing the network up. You divide it up into 500 hosts or less for each network. The reason why this is necessary is because, as we said, when a computer sends out a broadcast, all of the other computers stop and they listen. And only the computer that broadcast was meant for actually replies with the information. It's the problem where they all stop and listen. Whatever they were doing, they stop and listen. And if there are too many broadcasts, it means that the network will simply be paralyzed. It will be extremely slow or completely crash. It will not work. So that's why Cisco recommends 500 hosts or less per network. Now for a Class B network, where the first octet is between 128 and 191, we have 134 being the first octet, which makes this a Class B address, being between 128 and 191 for the first octet. Now the subnet mask for Class B network is 255.255.0.0. Now, as we said before, the part of the IP address that aligns with 255 becomes the network, and the part that aligns with 0 in the subnet mask becomes the host. So if you're assigning this range of IP address to your network, the IP address for each and every one of the computers on the network would start with 134.53. The third optex for each of the computers would range between 0 and 255. The last optex would range between 0 and 254. As we said before, the very last IP address would be used for broadcast. There are a maximum of 65,000 hosts on a Class B network, which will have to be subnetted as well into networks of 500 hosts or less. Now for a Class C type network, which runs between 192 and 223, we have an IP address of 204 as the first optex, which is between 192 and 223, so this is a Class C address. Now the subnet mask for Class C address is 255.255.255.0. So the first three octets of this IP address will be network. 204.123.26 will be network, and the very last octet here will be for the host. If you are assigning this range of IP addresses to the network, each and every IP address will start with 204.123.26. Changing any one of these numbers on a computer within this network would actually take that computer off the network completely, and it won't be able to communicate with the other computers. So every computer got to have 204.123.26. Now the .0 would change for every computer between 0 and 254. The very last IP would be .255, which will be used for broadcast, as I said before. So you have 254 IP addresses, which is well within the 500 recommended by Cisco. However, 254 can also be further subnetted into smaller groups for any particular local area network. I always like to draw a diagram to explain exactly what we're talking about. So in this diagram here, I would explain everything that we have talked about so far, so that if you don't have a full understanding at this point, this would bring it more together for you. Now, I have up here, first of all of the IP addresses that we're going to be using here. We are using Class C private IP addresses because we're in a local area network. There are two types of IP addresses, like we talked about before, public and private. I'm using Class C private IP addresses here, which is 192.168.2.2, 2.3, 2.4, and 2.5. Now, the subnet mask is 255.255.255.0. This is for Class C subnet mask. Up here, I also want to show you that an IP address range starts with the .0. However, you don't assign that IP address to any one of the PCs. This is the network IP. The network IP is for the network. You don't assign this one. You assign from 2.1 and up. And you don't assign .255 either. .255 is the broadcast IP, and I'm going to explain to you here how the broadcast IP works. We talked about it earlier, but showing you in a picture, you'll get a better understanding if you didn't understand it so far. Okay, so now we have, let's say for instance, 192.168.2.2 wants to talk to 2.5. Now, PCs do not communicate with the IP address. The IP address and the subnet mask is there to identify that particular PC and to relate that PC to the network. Like if I change any one of these numbers within the network part of the IP, all of a sudden this PC will not talk to any of the other PCs because it's not on the network anymore. So this network address 192.168.2 got to be the same throughout, and it got to have the correct subnet mask, because if one of these computers do not have the correct subnet mask, it would not be on the network anymore either. So this is how you identify a computer as being part of that network. But if this PC wants to talk to this PC, they talk to each other with the MAC address. And how this is done is that this PC wouldn't normally have the MAC address, especially if there's a brand new PC. You just install this system, you just put it online, and now you want to send from this PC to that one. There's no way you're going to have the MAC address for that PC. So what is done is that the PC would look into this cache to see if it has a MAC address for that PC. And if there's no MAC address, it will send out the ARP message. ARP stands for Address Resolution Protocol. This is a broadcast that it sends out, and it sends it out over this IP address, the .255 IP address. When this broadcast happens, all of the other PCs on the network just stop whatever they're doing and listen. In the broadcast message, it will be saying who is 192.168.2.5. None of these computers here are 2.5 except for this one. So this one would reply saying I am 2.5 and this is my MAC address. So now once the 2.2 computer gets its MAC address, now they can communicate and send data back and forth. Now this is the way it's done with any of the PCs here. So when I talked about earlier that you want to make sure that your network is not too big, like we were talking about Class A networks is about 16 million hosts. Well, that would have too many broadcasts. Like every time one of these computers want to send, it sends out a broadcast. 16 million computers send out a broadcast. All you would have is broadcasts on the network, and nobody wouldn't be able to communicate with each other. None of these computers won't be able to communicate very effectively. So that's why you want to have the network smaller so that the broadcast messages would be less, so that there will be more communication being done. That's why Cisco says 500 or less. The less, the better. The smaller the network, the better. The more efficiently, the less broadcasts you will have on a network. The next step will be to go to a gateway. The gateway is for if you want to get off your local area network. Right now you can only talk to PC on your local area network. What if you want to get onto the internet? How would that be done? And I'm going to show you that on the next slide. Okay, I went ahead and add a bit more to this local area network. Before we just had the switch and the 4 PCs, I went ahead and add a gateway. The gateway now will be programmed into each one of these PCs. 192.168.2.1 is the gateway. And if you look up here, you'll see 192.168.2.1. This is a part of the router that interfaces your local area network. So it has to be on the same network as the PCs. As you can see, the subnet mask and the gateway IP is on the same network. The only difference is the last digit. This is .1, .2, .3, .4, and .5. And another thing I wanted to touch on right now is that, you remember we talked about ARPing? When these PCs want to talk to each other, they got to get the MAC address in order to talk. Well, this ARP request stops at the gateway. Routers do not pass ARPs. So it stops at the gateway, it remains within the local area network. The reason why routers do not pass this ARPing, which ARPing is the broadcast that is sent out over the broadcast IP, as we talked about. The reason why routers do not pass that is because if it did, it would paralyze the entire internet, because you'll have every computer in the universe sending out ARPs that will be just paralyzing the entire internet. So this is not allowed. The ARP stops at the gateway. So now what the gateway IP is for is that if any one of these PCs wants to get onto the internet, let's say this PC wants to get onto the internet and it type google.com right in the browser, the switch will look at that IP address and realize that you're not trying to get to any of these computers, you're trying to get to a public IP address, so it will send you through the gateway. This router would route you to the public interface, which is a public IP address, 70.2.54.2. This is a Class A IP, the subnet mask, which is 255.0.0.0. Now, in order for this router to communicate with the distribution router, which is your ISP's router at the other end. Both routers got to be on the same network. This is how communication is done between IP addresses. So this router is a 70.2.54.2 and this one is 70.5.8.20. Remember, this is a class A IP address where the first octet represents the network. Once the first octet is the same and you have the same subnet mask, you're on the same network. The 5, the 8, and the 20 are all hosts. So once this has been established, communication takes place between the interfaces and your information is routed to the internet. This is the first of a series of networking videos that we'll be releasing right here on our YouTube channel. So if you haven't subscribed as yet, don't forget to click on the subscribe button below and then click on notification so that you'll be notified when our new videos are released. My name is Trevor from Telecom Training. Thank you for watching.